Hello, everyone. I'm Tor Norby from the Android Tools team. This is Romain Guy from the Android Platform team. And we're here to introduce this Kotlin talk because we both use and love Kotlin, and we're super excited that it's now officially supported by our teams.
Yeah, so one of the big reasons why we decided to adopt Kotlin was you guys, everybody here, all the developers who have been using Kotlin in their application, who have been asking about Kotlin. So we thought, usually it's Googlers on stage at Google I/O, and we decided that this time around we would have non-Googlers. So we have Christina Lee from Pinterest and Jake Wharton from Square. So they're going to do all the work, and Tor and I will just disappear. Enjoy.
Right.
OK, so hopefully all of you were in Hadi's presentation earlier today. He talked about the language and the language features outside of Kotlin, just the language in general. And today we're going to go through examples in Android, how the language features can be used to basically clean up a bunch of sort of rough edges of how you write Android code. So the first thing to start with is, here we have a boring main activity. And what's interesting to note is that this parameter is actually nullable. So if your app process is starting from scratch, this is going to be null. And the way that we've now represented this in Java is with nullable annotations, support annotations. And what's great is that as these have been being added to your code and support library code, when you start writing Kotlin, the fact that the method that you're overriding has that annotation means that Kotlin indicates that it's a nullable type. So all of the work that you've been doing to annotate over the last few years is now going to pay off in Kotlin, where the type system models nullability. Similarly, in Android 4.1, a lot of work was done to normalize the getters and setters on all the views. And if you saw, these are traditionally called beans in the Java programming language. And what's nice is that Kotlin takes these and collapses them into what's called properties. So in Java, you'd refer to them directly. But if we rewrite this in Kotlin, you'll see that we're referring to just an alpha property. And when we're reading from it, it calls the getter. And when we're writing to it, it calls the setter. So all of that work that was done, again, now pays off in Kotlin. OK, so here's some sample code that illustrates when you need to perform some operation over the children inside of a view group. View group is very similar to a collection, but it doesn't have any of the niceties of collections, like being able to use a for each loop. If we rewrite this in Kotlin, we get much more declarative syntax. The first thing to note is the range. Here we're using that infix function. And it actually will, even though it's a function, it's like an intrinsic in the compiler. So you still get a for loop that uses indexes in the bytecode. And then here you can see that the child count property that we're calling, again, comes from the get child count method, which is in Java. But we can do a lot better than this, right? This isn't that much different. It's just a little bit more clean. How can we make view group behave more like other collections? Well, you saw the extension methods. You can add an extension method to view group, which does this iteration. And then your calling code becomes much more like you would over a normal collection. And the nice thing to note here is that extension methods will desugar into a static method where the view group is just the first parameter. An important thing to note is, so this is a higher order function. It takes in a function as its parameter. This will actually cause an anonymous class to be created at the call site that encapsulates the code inside the Lambda. So this can become prohibitively expensive, right? If we're using all these higher order functions and creating all these anonymous classes, dex size goes up, method count goes up. What we can actually do is mark this as being an inline function. So this wasn't mentioned by Hadi. What it does is it basically takes the implementation of this method and inlines it into the call site. And so because the code has been moved, you no longer have to create that anonymous class. And so this method essentially becomes free to use. So one thing that you might have missed is we actually lost the ability to know what index of child we're looking at. But that's easily solved with a second extension method that allows the index to be passed in. And again, as an inline function, we have no additional overhead here. So that was for iterating of the child views. But there's a lot of other things we can do to view group to make it behave a lot more like a traditional collection. So for example, if we add a get method as an extension function, we can now pull out child views as if it was a list or array. We can refer to them by index and have that corresponding view returned. Key thing here, again, that Hadi pointed out, this is an operator function, so we're declaring that it has a special call site syntax. And that's what all of these are going to be. So how about adding and removing views? Well, we can add minus assign and plus assign, and so this allows us to use shorthand syntax for removing and, again, adding. One more would be looking up to see if a child's already in. And again, the implementation of these functions, we're just reusing the methods that you otherwise would have been calling, but getting a better syntax at the call site, which allows the view to behave much more like a collection. And so this wasn't highlighted in Hadi's talk, but it kind of looks like this is magical, right? When you're looking at the code at the top where you're using these operators, how do you know what implementation of that is actually running? Well, a cool trick in IntelliJ and Android Studio is that if you actually put your cursor on one of the operators, you can Command B into it, and it will actually take you to the corresponding function. So even though you get the nice call site syntax, you still have the visibility into what the implementation is doing. And if you want, you can actually call these methods as if they are extension methods, not using the operator syntax. Because again, they're just normal functions. So extending a type isn't limited to just methods. We can also add properties. And so how about adding the number of children as a size property, which is what a list or array would expose? Interesting thing to note here, again, using string interpolation, also mentioned in Hadi's talk. OK, this one's a little more advanced, but having the for each function that we added only allows us to do that type of iteration. Whereas a list, we have all these other higher order functions, filtering, mapping, that we can use that we can no longer use on view group because it doesn't extend that base type. What this code does, which you don't have to really look into and understand, is add the ability to create an iterator of children. And so now we get access to using the traditional for each loop. And if we want, we can use those higher order functions that exist, higher order extension functions that exist on iterable. So here I'm collecting the height of all the visible views, very declarative. And these, if they're inline functions, you lose the overhead as well. So extension functions are great for encapsulating repetitive tasks. So if you're using custom trace points as an example, I always forget to put the end section. And especially if you're refactoring code that has trace points in it, it's very easy to rearrange which end section is applied to which begin section. And it ends up screwing up the systrace output. What we can do is just go back and use this trick over and over again. We can encapsulate that code inside of an inline function. And so and this will perform the begin and end, and then it will execute our lambda in the middle. But as an inline function, we don't pay the cost of allocating anything. And so now our call site just becomes trace with the tag, and then whatever's in the body is automatically wrapped in begin and end. Another nice thing is that you can actually return from these functions. And so if you're computing something, we don't lose the ability to capture return value. OK, so Same tricks over and over again. A lot of times when you're writing the same boilerplate code, you can get this like tunnel vision where you lose track of the ability to differentiate whether something is correct or a mistake because you're so used to seeing it, you just gloss over. And so you might have missed, looking at this, that we're actually missing setting the transaction to successful. And so all the code in this block wouldn't have even ran. This is another one where we can just apply the same trick, write an inline function that encapsulates this ceremony around interacting with a database transaction, and then our call site becomes extremely simple and declarative. This one's especially interesting because we still have to refer to the database inside the transaction block. It would be nice if we somehow could associate the statements inside the block with the enclosing transaction, because we already specified it on the database, so it's redundant to say it over and over again. One way to accomplish this would be to change the lambda that's being passed into the function such that we inject the database reference back into it. And this allows our code, so we pass this into the body. This allows our code to refer to the it parameter, which is when there's only a single argument being passed to a lambda, you can just refer to it as it. This isn't as nice as it could be, though, because now every statement that we put inside this lambda has to have it prefixed in front of it. So just like we had extension functions, which add methods to a type, we can create extension lambdas, or as I believe Kotlin calls it, lambdas with receivers, where it's the same trick where if we change the parameter of the lambda that's being passed in to itself be an extension function of the database. This means that the body inside the lambda is going to execute as if it was a method on SQLite database. And such, we can call methods without having to qualify them with any reference. So now our call site only mentions the database once, and then we can just call the methods for performing inserts, updates, and deletes without having to qualify them with the database reference. OK, sticking with databases, doing inserts like this is not terrible, or deletes, I guess, in this case. But the problem is actually the database that underlies, that has to execute this. It has to parse the query every single time, figure out that it's syntactically correct, figure out where the question marks are that it needs to bind arguments into. And so if you're running this over and over and over again, you're basically wasting time in the database for having it to parse your query every single time. The way that this is solved in the SQLite APIs is by compiling a statement ahead of time and then reusing that over and over again. And so now the database only has to parse this once, and then it just it kind of remembers, creates a model of what the query is, and then when you execute it, it only has to insert the arguments and execute them. So this is nice. We get a performance win if we're calling this a bunch of times. But we actually changed this such that if we were calling delete by first name on a background thread before, this compile statement is going to run whenever this class is created, which is usually the main thread. And so we moved database work onto the main thread. The way that this is fixed is with a feature called Delegation, and this is property delegation. It's basically allowing you to supply code behind a property that can run whenever it's assigned to or read from. So in this case, what we're doing is we're delegating the implementation of this delete by first name property and to a Kotlin, built-in Kotlin feature, which is going to make it lazy. So lazy takes in a lambda now that only gets called the first time that you get the value from this property. And so what we've done is now allowed this to have the same behavior as the original, where it was parsed on the background thread, but now it only does it once instead of many times. There's a lot of examples of where delegation on properties can be useful. Another built-in one is observable, which allows the lambda that you supply to be called every time the property value is changed. So I write a new property to this name, and the delegate calls this lambda with the old value, the new value. For properties that aren't immediately going to be initialized, but that you know will very soon be initialized, instead of marking them as nullable, which requires you to initialize it immediately when the class is created, you can use a delegate that allows you to sort of defer setting the value. And so if you try to read from this without setting a value, it's going to throw an exception. But if you write to it and then read from it, totally fine. So and this is perfect for cases like activities and fragments where you don't control the creation of the class, but there is a method in the lifecycle that's very early where you usually set up these properties. And you can write your own delegate. Delegate's just a interface that you can implement. So we have one which allows us to bind views. So it automatically, if this is like in a view subclass, it will lazily look up this view the first time that you access it. Another feature of delegation is class delegation. So the transitions framework lacks a base class that you can extend from such that you only have to override one method. Wouldn't it be nice if we somehow could only override the method we needed and then have something else that we delegated to for those empty implementations? Well, you can do this. You can create a class. This is an object class, which is a singleton in Kotlin. And it has empty implementations of all the functions. And so now, on our original type, what we can say is that we're implementing transaction listener, but we're going to delegate every call to this singleton type, except for the ones that we override. And what Kotlin will do is basically just add the overrides in the class automatically, call the delegate for the ones you haven't overwritten, and your code that is overwritten for the single method will be used only for that one. For testing, we abstract away espresso. We have these things called robots, which are just kind of high-level methods that we can interact with instead of putting espresso in every single test. And what's great is that in Kotlin, we can call this in a very readable and declarative way. But again, another trick you can do is with these extension functions and lambdas with receivers is take that kind of weird-looking constructor initialization and the apply method, which doesn't really make sense in this case, and turn it into something that's much like a DSL. And so you can build these type-safe DSLs out of anything that any like domain that you have in your app. The testing is just one example. And so finally, sealed classes got to mention as well. So these are basically type hierarchies that are closed that other downstream consumers can't add an implementation of. A great use of this on Android is for recycler view payloads. So let's say you're displaying tweets, and when you click them or when you receive data from the web service, you want to update the counts and the icons. So we can write a sealed class for each of these events, which are the objects that we'll send to recycler view as payloads so that it knows to only change a number or only change an icon. And here we're using data classes, again, also mentioned. And what's great about this is we can use a lot of the language features to make this really readable on the consuming side. We get the nice looping with the lambda. Then we can use the when block, which allows us to do the smart casting. So for each of these branches, they have associated properties in the data classes. So each one can now reference the properties without having to do the explicit cast because the when expression took care of it. And so we add the other branches. And we get this nice readable payload implementation instead of what we have in Java, which is a bunch of objects and a bunch of manual casting. And so hopefully all these examples have really resonated. I mean, there's so many things over and over that we do in Java that we can take the features of the Kotlin programming language and apply them to make the code more fun to read and more fun to write. And so now I'm going to turn it over to Christina, who will talk to you about how you can adopt the language in your organization.
Thanks, Jake. So, hello. I just want to start out by saying we're here. This is I/O 2017, and we have a session about Kotlin. A lot of people who made that happen, they're in the room, both the Googlers and the people from JetBrains. I know I appreciate it. Can we give them a round of applause? All right, so it's been a journey, not as long as it could have been. It's been pretty swift, actually, but it's been a journey. A lot of us have been out there talking to people and evangelizing Kotlin. And at first, there were some objections, like, hey, this language isn't finalized. Are you sure we should use that in production? But as time went on, that was solved. We now have our 1.0, and we've had a lot of great releases since then. But I can guarantee that anybody who's talked to anyone about Kotlin has always fielded exactly the same question. And that was, so what does Google think about this? And this is great, because of course now I can stand here and say, solved problem, this is my last slide, goodbye. But it's not actually that easy. Because of course, this is like one of those situations where your friend says, hey, do you want to run? And you're on the couch watching TV and say, sorry, don't have running shoes, shucks. And then they say, it's OK, we can just do push-ups. You don't need equipment for that. We've taken away that first layer of excuse. It's the pushback that we got most often. And now we don't have that pushback. We have a stance. We know where we stand. But that doesn't mean that there's no work to be done now. There's quite a bit of work, actually. And so I'm going to talk to you about how to do that. A lot of the experience will come from my mistakes, but also from a lot of you in the community that I've been talking to. So I like to break this down into 3 steps. The first one, and the easiest, is you. You control what you say, you control how you say it, and who you say it to. That control, it gives you a lot of power. The second one is management. This is often the elephant in the room, but we have some strategies to make it easier to talk to them. And last, and I leave it last on purpose because I truly believe it's the hardest part, is getting buy-in from your team and creating an environment where when you introduce a new tool, everybody that you work with can be as successful and as productive as you are with it. So let's start with you. I have this quote here that has absolutely nothing to do with tech. It's a very grandiose quote, and the essence of it is that the only thing that's ever created change in the world is a small group of people who have cared deeply. And I know that we're not usually here to change the world. We're here to change code bases. But the reason I include this is because the language of influence is applicable to all of us. This happens in industries all around the world, and we don't get to escape from it. I know that a lot of people in this room are saying, but wait, I'm an introvert. I don't know if I can go on stage and do a dance and shout, go Kotlin. And I'm not asking you to do that. There are a lot of ways for you to show enthusiasm and to be passionate. You can tweet about it. You can send a Slack message to your best friend, an email, an SMS, an MMS if we want to go back 10 years. It doesn't really matter. There are a lot of ways that you can communicate that you care. But the important thing is that you do communicate. Because, of course, if you're sitting here waiting for the people in your office to be struck by a thunderbolt and suddenly understand the awe-inspiring nature of nullable types, you're probably going to be left waiting. So be enthusiastic and share that enthusiasm with other people, no matter what that looks like. But the corollary to that is that the easy part is being enthusiastic. It's a great language. It's not that hard to get excited about it. But you also need to sign up for what comes with that, which is that people will have questions. If you have a build system completely based on the Java programming language, and you introduce a new tool to it, there's a good chance that it might hiccup, that something might not go exactly as planned. And you need to be there to make sure that you can fix that. Because if you care enough to introduce a new tool, you also need to care enough to be a steward for it. That's all I'm going to say about you, because again, it's the part that you control. It's the easy part, right? Just get excited. It works. Now, management. Management is the elephant in the room. I started by saying, hey, the #1 question I got was, what is Google's stance? But of course, the #2 thing that I talked about with the community was, I'm sold, I love it, but I can't convince the people in my company that I should be allowed to adopt Kotlin. So let's talk about that. I have been on stage and I've said, hey, there's this magic argument you can use. You just walk into someone's office and then you say, give me this language and I'll give you an NPE, or relatively NPE, free app. I say relatively because where there's a will, there's a way. But this is a great argument. The more I talked about it with you in the community, though, the more I realized that it boils down to something much more fundamental. And that is that Kotlin and languages like it, they help us offload things that we're not that good at onto our computer. And we already do this a lot. The way I know that we do this is that we all collectively freak out anytime our computer breaks. I know I do it. I've seen other people do it. And that's because computers are fundamentally a huge part of our life. They're really, really good at doing the things that we're really, really bad at. And that frees us up to do some of the more creative thinking, the architecting, the making sure that it works for your coworkers. All of these more creative and critical thinking tasks are things that we get to focus on more. And when talking to management, this is something that they understand. They're going to have questions, yes. But if you move this conversation onto the plane of, hey, I have this tool, and I want to use it more effectively, people understand what that means. So of course, one example of this from Jake is just saying that types are a form of testing. And whether you fully agree with this or not, the underlying sentiment is that we are catching errors sooner. And we're doing it without having to keep it all logged into our head. And since we don't have to juggle the 10 different places that something could be null or mutating or any of those other variables, it gives us more time to think about other stuff. So, sorry. This is my favorite photo in this slide deck. The point here is that people and companies are risk averse. And the reason they're risk averse is because someone's job out there is to make sure that your company doesn't burn down. And that's a very noble profession, and I appreciate that they're there. So they have to keep us in check. And that means that when you're communicating to them, you can by all means feel free to say, there's this thing called val, and then you change one letter and it's a var, and it's magical and it's revolutionary, and you're going to love it. And if your manager's really cool, maybe they'll understand that. But for a lot of people, that's not going to be a really persuasive argument. And it's because even if they understand that from a technical level, it doesn't have resonance. So talk to people in a language that they understand. Talk to them not about the methodology, but about the end goal, which is to say, instead of saying there's typed nullability, say, I can provide you an app that's more stable for our users. It'll crash less. The users will be happier. Or if your management, like mine, values moving fast, say, hey, I have a tool, and if you allow me to use it, I can make more reusable code, and I can iterate faster, and we can get more product out the door. Again, feel free to talk to them about Kotlin. I am never going to discourage anybody from doing that. But also step out of your shoes and into theirs. And talk to them at a business level about what they care about. OK, last and hardest, the team. Now, this is a really good place for me to add the caveat that I'm here because I've made some mistakes. And I want to share them with you so that you don't have to make the same ones. I'm sure people will find new ones to make, but at least they won't be mine. So to start, define success. Know what that looks like for you. And I say this because I was out on the grass when we announced that Kotlin was going to be supported, and I heard a lot of you saying, hey, cool, so does this mean that I can just convert my whole code base to Kotlin? And I said, whew, yes, I mean, if that works at your office, by all means. But what I've learned in my Kotlin adoption was that if you do that, you're going to have to put up with grumbling for months to come. And the reason for that is that teams, they're made of diverse people. And diverse people almost never agree unanimously. Which is to say, if you're in a startup with 2 people, maybe you can go to lunch and agree on this and push the code that day. But if you're in a bigger company and you have 30 or 40 devs on a team, getting them all into a single room and agreeing on something is going to be time-consuming, and it's going to take effort. And so when defining success, I would again encourage you to focus on the outcome. If you want to stand there and say, Kotlin is the best language, you can, but I guarantee someone will stand up and want to argue with you, because it's fun to argue, and developers love to do that. I'm one of them, I know. So what I would encourage you to do instead is say, we want a stable code base. We want to hit this metric for number of crash-free sessions. We want to be able to iterate faster. Any of these things, it's easy for people to agree on. They're not controversial statements. And if you start with a common goal with your team, then when you say, hey, there's this tool, it'll get us to this goal in X, Y, Z steps, it's a lot easier to have that conversation. You don't have to start a flame war. You can sit there and you can dissect pieces and have productive conversations on smaller chunks. Now, part of this is also getting stakeholders on board, which is something I mildly did, but also mildly didn't. So the importance of this is that if you're like me, and you're a developer and not in the management chain, it means that if anything goes wrong after you adopt a new tool, like Kotlin, someone above you in that chain is going to be on the hook for it, which is great for me, but less so for them. So there's also this dynamic, too, that consists of you standing here saying, hey, this is a great language, and then someone going off and saying, hey, have you heard about this language? Christina says it was great, but I just wanted to hear your opinion. And for both of these reasons, you want to make sure that the culture setters in your company are on board. Both because if something happens, you want them to have your back and to say, this is the right path for us, it's worth it to push through this, let's just fix it. And also because if the culture setters in your company aren't on board, you're going to have a lot of dissent. And I know we can get complacent because the interop is so good between the Java programming language and Kotlin, but it's really not a great place for your team to be. Oh, there we go. Now, also, find someone who reviews your code like this, exactly like this. I do this for my team. I've been known to skip around my desk. It's happened. Ask any of my coworkers in the audience. And you should find someone in your company who feels exactly the same way. And the reason I say that is that, again, in talking to the audience and to members of the Kotlin community, a lot of you had said, I just snuck Kotlin in, and it was great, and nobody knew. Now, one, do you all still have jobs? Like, how is that working for you? I mean, we need to talk. I don't know about these rogue commits that are just coming up left and right. I appreciate the spirit, though. And two, that means that you shoulder all that work on yourself. And I don't know about you, but I'm already pretty busy. I got a lot of emails to write during the day. And so if you can find people who feel like you to work with, that's going to make your job less hard. And the other reason this is important is that this language, although it's been around for several years now, is just hitting widespread adoption. And what that means from your perspective is that we don't have 20 years worth of code styles to fall back on, and best practices, and books, and all of the things of that nature. And that means that when you introduce Kotlin into your code base, you get to have those conversations. And as a developer, that's fun. But it's also time away from your work. And what does this look like? It looks like you adding Kotlin to your code and having almost, 2 ways to do almost exactly the same thing. We need to standardize our code base, ergo, what is my company's position? Which one do we default to? I've also heard from the Trello team that they have a lot of conversations about what it means to be null when we have typed nullability. This wasn't a conversation that we had to have before, because by default, most things were nullable. But now that we control that in a much more concise way, what does it mean? You need to decide. Is it valid for me to make this thing nullable? Or is that just completely illogical for the data structure that I'm building? These conversations, they need to be had. And while you can have them with your whole team, you can dive in and say, we're all on board, it's going to get noisy. There's a lot of thrashing involved in deciding what your future looks like. And so this is why I would recommend finding a nucleus and working with them. It should go without saying that I also hope that you document all of this, because at some point you should bring everybody else on board. And of course, I'm not saying not to get opinions. I'm just saying that if you try to adopt by consensus, it might not move you along as fast as you would otherwise hope. Now, I also want to point out something. This is from Dan Liu's blog, about what you're expecting from your coworkers when you ask them to adopt a new language. And that's that you're asking them to go from a place of expertise to a place where they're new again. And yes, JetBrains has done everything in their power to make this seamless. The IDE support is great. You can copy and paste for convert. You can right-click convert. You can have hints in your IDE. You have the compile time errors. They have smoothed the way for you, and it is easy, way easier than anything else I've adopted. But that doesn't mean that there's no work. And so people, when they use the Java programming language, are often coming from a place of having used it for years. And that means that they know all of the little tricks. They've read all the interview books. They've read the blog posts and the puzzlers and all of those things. And so they know those tiny little edge cases just from having been in the environment for ages. And when you come to a new language, you don't necessarily bring that knowledge with you. A lot of it is still applicable. But you also have to expect that there are going to be some times where you haven't found all of the edge cases and you're going to be burned by them. And so if you're asking that of your teammates, you need to make sure that onboarding is a first-class citizen. And I know this isn't that exciting. We're all developers. We want to code. Who wants documentation anyways? But it really, really is important if you want Kotlin to be successful in your company. And that's because you can say, oh, well, everybody on my team right now, they know Kotlin, so we don't need to onboard. But what about when your interns come in? Or when you hire someone new in 2 months? We are not at a point in the industry right now where we can expect that everybody walking through our interview pipeline knows this language. And so if you throw them in the deep end without any flotation device, that's on you. And you should expect them to feel lost and overwhelmed. So make onboarding a first-class citizen. Think about it early. This probably means that you have to change what you're doing in the first 2 weeks that your employees arrive. You'll have to update documentation, code examples, make sure that they have the tools they need to run this new language, and probably do some mentorship as they learn the language on the job. Do that work. It's really important, and I know because I put it off. So don't be like me. Get it out of the way early so that you don't have a bifurcated team. Again, interop, it has all of the merits, right? It's great. But it can also make us lazy because we can say, they don't need to use Kotlin. They can use Java. But Kotlin, it's here to stay, and we want people to enjoy it, and we want them to partake. So just saying, you don't need Kotlin, you can use Java, it's not the best route, really. Now, my only last remaining point, show up. Be there for the work that needs to take place, that documentation updating, that advocacy. We all know Jake's white paper from several years ago. That didn't just poof into existence. He sat down and he wrote it. And I know at my company we've had those moments too. We've done the behind-the-scenes work that has made the adoption during the workday much more successful. And it's not glamorous, I know. But if you want Kotlin to be successful in your company, it's necessary. And now that I've bummed you all out and told you how hard this is all going to be, I just want to remind you where we are. We have official support for Kotlin, and that's a great place to be. So yes, there's work involved in it. I know, and it's not sexy work either. It's not as fun as writing Kotlin, but it's worth it. We have the chance to use an amazing language, so let's put the work in to make it happen. Now, I know a lot of you after the keynote were asking, hey, I'm interested, I'm sold, how do I get started? Well, here are a few resources. Predictably, I have links to both the Android documentation and the JetBrains documentation. On that JetBrains site, you'll find koans, which are ways to go through coding exercises and explore the language incrementally, as well as the standard documentation and a REPL. And then, obviously, there's a book that came out about Kotlin recently, and I would encourage you to read it. That's all I have for you today. There's no time for questions, but we'll be outside after this presentation. Thank you.
Thank you for joining this session.